Good afternoon, guys. So today we go all the way to Levey Mwanawasa University, tutorial sheet 3. It's on forces. So there was this question that's been flashed on the screen. Two boxes are connected with a massless cord and are resting on a frictionless table as shown below. The masses MA is equal to 10 kilograms and MB is equal to 12 kilograms. A horizontal force FB, that is 40 newtons, is applied to MA. Calculate A, the acceleration of the boxes, and B, the tension in the cord connecting the boxes. So now there are things that we have to note in this question. First of all, the cord is massless, so you don't have to actually consider the mass of the cord. And then two, the surface is frictionless, so we don't have to consider any coefficients of static friction. And then we will take FP as the only force, so which means the force that's been applied is the only force. So these are ideal. This is an ideal table, and this is an ideal cord because it doesn't have mass, and then the table also doesn't have friction. But then in reality, there is always at least an amount of friction, and then we know a cord has to have mass at least, but then we assume that so that it can be easier in our calculations and for the fact that it's negligible. So then we go straight right into it, and then A, find the acceleration of the boxes. So there are complicated ways of solving this question, but then this question is actually easy. So we have a table. Remember to always draw your diagram. We have a table. We have a mass that's being applied, FP. This is MA. This is MB. So now we write our data. This can earn you a lot of marks. MA is equal to 10 kilograms. MB is equal to 12 kilograms. FP is equal to 40 newtons. And the acceleration, we don't know. The tension, we don't know, but then we are about to know anyway. So now we go to A. So we write Newton's second law, which says force is directly proportional to the mass. Force is directly proportional to the mass and the acceleration, and acceleration is directly proportional to the force and inversely proportional to the mass in the direction of the force. So Newton's second law is like that. That's how it just goes. So now we can plug in the values, but then remember we are trying to find the acceleration, and then the mass is of two masses, so we'll treat this as though it was one box. You understand? Because that's the only mass that we're looking at, and the mass in the cord, we ignore it because the cord is massless. So we have our force being equal to mass of A plus mass of B A. So now we divide both sides by MA plus MB, MA plus MB. This will cancel, and then we have our acceleration being equal to the force over the total mass, MA minus plus MB. The acceleration is equal to, we know the force is 40 newtons, the mass is 10 kilograms, the other mass is 12 kilograms. Then when we add this, we're going to have a 22, 40 on top, so the acceleration is equal to 40 divided by 22. So now you can round it off to two significant figures, to two decimal places rather, meters per second squared. And then for part B, the tension in the cord. So now we can go back to Newton's second law. So this is A, and then we can go to B. So the force, now the tension force is equal to the mass times the acceleration. Which acceleration and which mass? So now the tension in the cord connecting the boxes. So it's actually this tension, not this one. We're considering this tension. So now this tension here, we can consider it looking at this mass. You understand? We'll consider the tension with respect to this mass, so we only consider this mass. So because this tension is here, we can say Ft is equal to the mass mb and the acceleration of b, right? The force tension of b. Now we have many subscripts, so the force tension is equal to mb. So now mb is this one. Now what's the acceleration of b? Now remember, these are together, so the acceleration of this one is actually the acceleration of this one. So this acceleration that we found can work also here because they both face the same acceleration. So we're having mb is 12 and then acceleration of b is 1.82. So when we multiply 12 by 1.82, we are going to have our force tension being equal to 21.84 newtons. That's all for our problem. It's very easy. So you can keep sending the problems to 0978959797. That's all for now. Thank you for watching. Subscribe, share, and always remember to give me support and share with a friend that you think will actually benefit from this. Thank you. It's goodbye from me.